Okay, welcome back, and it's time to move on. We're gonna really get down to building this actual robot. So one of the things we're gonna have to achieve is we've got to somehow sever this project we've been working on from its USB cable and make it so we can run it on batteries. We have a couple of issues we have to deal with that. One is we'd like to have the motors get lots of robust power so that we have plenty of power to play with so the robot moves around nice and neat. And yet we have to be able to carefully set a regulated supply of voltage to the teensy 3.1. And the teensy can handle a range, which is kind of cool, but it maxes out at 5.5 volts. You really shouldn't put anything more than 5.5 volts into it. It'll drop down to 3.7, which is a pretty good range to work with, but we still have a range. And if we're going to do something like use the battery packs, which are included with the robot kits, that's going to have 4 batteries in it. If I buy alkaline batteries from my local Walmart or wherever, they're going to be 1.5 volts a piece. So 4 times 1.5 is going to be 6 volts, which means that we can't safely run the teensy directly from 4 alkaline batteries. We could run it off of 4 rechargeable batteries, because rechargeables are a little less voltage. They're about 1.2 volts per cell, or 4.8 total. So we could run the entire thing directly. But what ends up happening is sometimes when those batteries start to get a little weak, the starting up of a DC motor causes a little transient voltage drop. Okay, so as soon as it kicks in, they're at a stall state. They're not moving, and inertia and turning all these gears and getting things moving sucks in an awful lot of power. And when that happens, we get this little drop in voltage. Sometimes it drops below the cutoff of 3.7 volts. Okay, so then we get this erratic behavior as the processor resets. We have this thing where the robot starts twitching around, which is kind of annoying. So what I'm going to do in this video is, hopefully in this 15-minute allotment, is 2 things. One is we're going to separate initially the motors from the USB, because you've probably, as you've played with it, you've seen it's not really powerful. Sometimes you have to give a little twist to get it going. And we're going to put the batteries on voltage, and then we're going to build a small voltage regulator that'll run off the same set of batteries that we can use to power the processor. And I should mention some of the sensors. Some sensors, like the rangefinder you're going to be using, they need 5 volts. So if we don't have that coming to it, they get false readings. So having a stabilized voltage source is going to be important. So at any rate, let's get the silly motors running on their own power first, which is really simple. And I'm going to zoom in a little bit here, because this is where we're going to be working back here. Okay, so that's my motor driver, the 293. These 2 wires here, these 4 wires are the motors itself. And you may recall that this wire right here is the one that supplies the voltage to the motors themselves. This wire up here supplies the voltage to the chip. Okay, this wire makes the logic work. This wire makes the motors work. Okay, so what we're going to do is we're going to first off remove this wire. We don't need it anymore. Okay, and then let's plug in a battery pack, and I'm going to put the black wire anywhere on the ground bus. Maybe I'll move it up a little bit so it doesn't give us that funny twist. There we go. And let's actually zoom out just a teeny bit again so we can look. If you've built your board like mine, and it's certainly worth checking, this entire row here should have nothing in it, closest to the red line. All right, nothing is in it. So what we're going to do is we're going to dedicate that entire row, all of these along the red bus, okay, are now going to be supplied with whatever we have in our battery pack. I have 4 batteries, 6 volts. Okay, so currently this entire strip is going to be supplying a positive 6 volts. So if I take a small jumper wire like this one and I simply jumper it between that positive bus and that pin, the one down here lowest in the corner, I should now be supplying my motors directly with 6 volts of power. So let me zoom out a little bit more so we can actually see those motors. And I'm going to load a bit of code. Let's go to that one we just did, the 2 motors mapped, and we'll load it up. And hopefully what we're going to see is a much more responsive system. Okay, these motors will have a lot more power because they're getting it now from batteries. You can probably hear the difference, and you certainly can see it just jumped right off. And yet we still have all our same logic control, right? Because our logic is still being supplied by the USB. So let's pull up that piece of code that we use to stop the motors. Alright, and what I'm going to do now is I'm going to zoom in a little bit. Okay, so you can see here what we've done, right? We've hooked up the battery to this long empty bus, previously empty bus, and the same common ground, and all I've done is jumper straight from someplace on that positive bus to the pin that supplies voltage to the motors. Okay, now we're going to work on this end of the chip. I'm going to pause this for a moment so you might see an awkward sort of break, and we'll be right back. Okay, so let's start working on this side of the board. So to do that, we're going to need a couple of components. We're going to need the, whoops, I dropped it, the 7805 voltage regulator, which should be available to you. The couple of capacitors, I should hold it up here, right? A couple of capacitors, and some wires that have been cut. Let me zoom back out a second. Okay, so I've got some wires that I've cut to nice size, staple size, that we're going to be able to use to build this really simple circuit. But let's take a look at what a 7805 really is. The 7805 or the 78S05, depending on which one you get, is a voltage regulator. And I want to show you some images here so we can see exactly how it's laid out. You can see that if I hold it in this orientation, the input is going to be over to the far left while it's laying flat on the table. The output, the 5 volts coming out, is going to be over on the far right. The center pin is going to be ground. Okay? Now, the 7805 is not perhaps the best choice. If you were into these kinds of things, you would say, well, Brian, we only have 4 AA batteries. That's going to be about 6 volts. And the 7805 requires at least a minimum of a 2 volt change, which means that if I input 6, I'm probably going to drop down to closer to 4 or even a little less. That's true. But what is kind of nice is I'm mostly interested in just protecting the circuit. And as we move on, we can increase easily to a 6-pack of batteries, and we're going to run really fast with our motors and flawlessly with our chip. We can split it. We can make it a 9-volt power supply specifically for the logic, and we can continue with the 4 or 3-cell pack for running the robot. What I'm really mostly concerned about is protecting the circuit. So in this particular case, actually brand new batteries tend a little bit over 1.5, so it's going to work just flawlessly. You'll see as the battery voltage drops and the batteries wear out, we're going to start seeing some erratic behavior. But again, it's nothing more than adding an additional cell to the pack, and we've got it corrected. So I'm a big advocate of just sort of building in this little bit of safety, realizing that this guy right here, the 7805, is not ideal. Okay? But it's going to work just fine for what we need, and it's going to allow us to expand out as we move on and be able to run it with multiple batteries. So let's get going. Back to the diagram real quick. Okay, with the 7805 voltage regulator laying down with the heat sink on the back, the one on the far right is going to be your input. This is going to be your supply coming in. It's going to be your 9-volt battery, your 12-volt battery, whatever it is. The ground is going to be common. It's going to hook up to the standard bus, and the out is going to be our regulated voltage. All right. So what I'm going to do is, you can see that this fits perfectly into just 3 holes that are right next to each other. Okay. So what I'm going to do is actually, I'm going to put the wires in first. I'm going to set, I need 1 red wire, okay, which is going to ultimately go to my positive bus. Okay. Immediately next to it needs to be a black wire. I guess it doesn't have to be red or black, but it certainly makes more logical sense. That is going to be my common ground. So if I insert this then in here, just like so, okay, you can see that my output is going to go to this outer red bus. I should use a screwdriver here. This outer red bus, and the ground is going to be hooked to the common ground. Okay. Now, I'm building it up here for a reason, because right now, if I load this code, all right, I still have my USB hooked up, and I have logic supply coming from the USB. What I don't want to have happen at any time is my USB connected while simultaneously running the logic off the batteries. All right, probably not going to be a problem. It hasn't been yet, but I do know that it's possible to burn out your USB ports. So I'm going to build this in such a way that I cannot do that. So I'm going to unplug the USB, okay, and I'm going to use this little red wire to connect to that bus, which is supplied to my battery pack. All right, and I'm going to use a jumper like this one that's going to connect between the input pin of the 7805 and this pin here. All right, so now you can see that I can't conveniently plug my USB in while it's powered by this chip. So to plug in my USB, I have to unpull it, the jumper, insert the USB. Let's load up a piece of code. I've only got a minute and a half. Should work. Let's turn on these motors. And come on. I'm going to zoom this camera out so you can all see what's happening. Okay, so the motors are working, everything's great, and you say, oh, wait a second, I want my robot to go all by itself. All right, I want to be autonomous. I can pull that out, everything dies, and if I plug this in, okay, now I'm running my logic through the 7805 voltage regulator, even though it's not ideal. Everything is working, logic is powered, motors are running, and I cannot simultaneously conveniently plug the USB cable in. To program it again, I have to pull it. My motor start up. Let's go to the shut off. And I've only got 30 seconds left. And I'm off. Okay. And then I do this. Plug it back in. And I am now running motors off. So I will see you again here shortly, and we'll continue to move on. We're about ready to build a robot.